Hello everyone, welcome to lab 3. In this lab, we are going to have an introduction to our synthesizer, that is USYS. We will see how to invoke USYS and how to synthesize our design. So I want you guys to recollect the session we had related to introduction to USYS, where we see that we will be reading the Verilog files, we will be reading the .libs, and then we will be writing out the netlist. Okay, so let's get started. So first command is to invoke the USYS. So to invoke USYS, I'm going to type USYS. This will invoke USYS. Okay, if you have done, we had our introduction to the lab session where I explained you to install the VSD flow. When you install your VSD flow, USYS will be automatically installed. So we are in the USYS prompt now. Okay, I'm just exiting here to show the current working directory. If you see, I am in the directory called Verilog files, and if you see where I am in the directory which you got it by cloning the GitHub link. So you will see the mylib and Verilog files, and I am inside the Verilog files folder. Okay, and all our libraries will be in the mylib. Okay, so that libraries we will be using for our synthesis. So I invoke USYS again. So this is the USYS prompt. Okay, so the first thing we will do is to read the library. So the command to read the library is read liberty -lib. Okay, and I'm going to give the path. Where is my path? You can give the absolute path or relative path. Anything will work. I am presently giving a relative path. Mylib. Inside mylib, you will find a folder called lib, and inside that there will be our Sky 130 library. Okay. 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 Kindly note the library has a special name. I'll explain you what is this name also in the subsequent session. Okay. The library has FD, SC, HD, TT, 0, 2, 5, 1V8, all those things. We will see what all these parameters correspond to in the subsequent sessions. Okay. Kindly note this and keep. Okay. Now the second step is to read the design. So the command to read the design is read Verilog. So in this example, we are going to read the Verilog file called good_mux. Okay, good_mux.v. I'm going to read. So there should be no error. So kindly note, you should get whatever file you are reading, you should get the successfully finished Verilog frontend. This command, this statement should be printed. That means our Verilog files are read successfully. Okay. In case our design is spanning more than one file, we need to read all the Verilog files. Okay, that example also I'll show you in subsequent steps. So read Verilog good_mux.v, we have read. Next step is to say synth-top. This step is telling what is the module I'm going to synthesis. Okay, I'll explain to you why we have to specify synth-top in the next theoretical session. Kindly pay attention to it. So synth-top, and we have to tell the module name which we are synthesizing it. Okay, synth-top and the module name which we have to synthesize. So the module name which we want to synthesize is good_mux. So good_mux is what I'm going to give. And let me open the Verilog file also here for your reference. So good_mux. So if you see, again, this file, this is mainly from an illustrative point of view. So as I told you earlier also, there are more than one ways to code a mux in Verilog. We wrote this file with a certain intention in our mind, which we will be seeing through why and what of this in the subsequent session. Okay, so as you can see, this is a mux. So there's a select line, and based on the select line, it accepts either the output is either assigned to I1 or I0. Okay. And as we can see, this is purely a combinational logic circuit. There is no sequential logic in this file. Okay, So since that means there is not going to be any flop present in the design. If there are flop present in the design, we need to execute one more command, which we will see in some other design. Okay. So now we need to write the Verilog file. Now we have read the design, we have read the Liberty files, that is the library. Now it is the time to generate the netlist. Okay. So the command to generate the netlist is abc-liberty. And the path to the .lib / mylib lib sky. So abc is the command which is going to convert our RTL file into a gate, and what gates it has to link to, that gate is what is specified in the library here. So the logic of good_mux will be realized in terms of the standard cells available in this library. That's what is the meaning of abc-liberty. So we are specifying the library file which I want to realize it. Okay, and kindly note, it prints a lot of messages here. Kindly note, it has inferred. So it has 3 input signals. Kindly note, it has inferred what all cells it has inferred. It gives you a report. This is a very important thing. We need to pay attention to these informations. So if you see, it has identified 3 input signals, 1 output signal, 0 internal signal. So I'll open the Verilog file also for your reference side by side. We can see what it is. good_mux, correct? So if you want to see good_mux, this is the file called good_mux. Let us keep it side by side and see. So if you see, there are no internal wires in this design. So you can compare it, correct? There are no internal signals, correct? There are no internal signals. There is only input and output. And input, there are 3 input signals, I0, I1, select, and output, there is 1 output. And kindly note what all cells it has used. It has used 1 clock inverter, 1 NAND 2, 1 O2 AI cell. Okay, it has used these 3 cells. Okay, now if you want to see what logic it has realized, the command to see the logic it has realized is show. When you say show, it will show you a graphical version of the logic it has realized. So this is the logic it is realizing. Interesting, right? See, now you can see the mux is completely realized in terms of this Sky 130 library which we used. Okay, now let's see what it has done. Okay, so let's see what it has done.